So I want to thank everybody for coming as we get ready to kick off our March lunchtime expedition lecture here. Just a couple quick announcements before we get going. I'm going to kill the lights here. My name is Corey Anko. If you have not met me yet, I am the curator of the Draper Natural History Museum here. We are really pleased to be able to offer these programs. We thank you all for coming to make this possible. Just a couple quick announcements. This is going to go for myself as well. First and foremost, if you just do this with me, take your phone or your mobile cellular device out, put that ringer all the way on silent or on airplane mode, and turn that off. That would be great. We'd really appreciate that. These lectures are being recorded and uploaded to our YouTube channel, so if you've missed any of the lectures previously in 23 or 22, if you go to youtube.com, type in Draper Natural History Museum, you look for our bear logo, you'll find all of our lectures there, and they're also in playlists to make it easy. If you'd like to be added to our email list, we send out an announcement every couple of weeks advertising our upcoming speakers, so please come find me, flag me down, we'll get a name and an email from you, and we'll get you on the list. So we've been really fortunate to offer these programs for free thanks to generous support from sponsors like Sage Creek Ranch and the Nancy Carroll Draper Charitable Foundation. And while many of our speakers are local, several of them do travel. Our speaker today traveled all the way from Lander. And so we are really grateful to be able to provide these lectures through our sponsor support. If you feel compelled or are interested in donating to help support these programs, please come find Amy or myself. And we'll help you get set up to do that. Today, we are going to hear from Jacki Klancher. Jacki has been leading mountain expeditions since the early 90s through her work with the National Outdoor Leadership School. Some of you may better know that as NOLS, based in Lander. In 2014, she began combining backcountry travel with scientific research, like a true adventure scientist. Over the past decade, she has worked with a number of critical partners to design research expeditions for undergraduates across the globe, from Wyoming to Tanzania, and most recently to the Everest Base Camp. Though the destinations are distant from each other, the complex challenges facing high elevation environments are not dissimilar. Jacki plans to continue to document changes in alpine environments and share her work with students and the public in her current role as a professor of environmental science and health and the director of instruction and research at the Alpine Science Institute. When she's not gallivanting in the Alpine with students, you can find Jacki planning an extended backcountry bike trip. Without further ado, please welcome Jacki Klancher.
Thank you so much, Corey, and thanks everyone for having me. This is full circle for me. Dr. Chuck Preston was my graduate advisor. We worked together on a small mammal ecology and fire ecology project in Ten Sleep many, many, many years ago, and so I'm delighted to be back. So thank you so much, Corey, for having me. Thank you to the Draper, and thank you for all having me. So I want to take you on a little journey today, and this journey is at the intersect of glaciers, graduates, the students I work with, and geospatial science and environmental science and hydrology and glaciology, et cetera, but we won't ramble on about every last type of science. And I want to intersect that with my role as a community college professor, an outdoor educator, and my own scientific research that I'm doing in the high elevation regions, primarily of the winds. And what we're looking at doing is how this serves our students and how this helps set them up academically and professionally for what is a complex future, whether that's in respect to climate change or just into the world of technology and a rapidly changing planet. So the goal of all of our programs, essentially, at least the ones that I conduct that intersect science and expeditions, is to really put students at the center of climate and glacial-hydrologic programs that really give them both professional and academic preparation for the future, but also engage them at a leadership level and an interpersonal level, and really help share the stage with everybody. And we'll talk more about that. We'll start kind of where it all began, looking at glaciers. And in the upper left, of course, the Dinwiddie, because that's really where it all started for us. But we'll also take a little bit of a journey to other places we've been more recently, which includes Everest Base Camp in Nepal, another environment that's experiencing tremendous change and tremendous impacts on glaciological and hydrological environments, and Mount Kilimanjaro as well. And before I dive in too deep, I can't stress enough, just like the Draper looks to you to support the work that we do, this work would absolutely not be possible without Wyoming EPSCoR, IMBRI, and NASA Space Grant Consortium, and without the Lewis-Stokes Alliance for Minority Participation. We're a participant in a suite of members in that group that's out of Colorado. So I'd like to give a nod to those folks and, of course, to Central Wyoming College. So from Glaciers, we'll discuss our graduates. Who are they? What makes them special? What do we do that's different than other colleges, an open access community college in Central Wyoming, to serve these students, and where they end up? From there, we'll start to weave in some science, geospatial science, but many elements of science, and at its core, a lot of geographic positioning systems, geographic information systems, global positioning systems, ground penetrating radar, some real hard skills, and then applied skills that we use to assess change over time. And ultimately, we'll bring it all together and see how this intersect of the skills that I brought and my desires, the needs of our students, Glaciers, geospatial science, and our graduates came together to form ICE, or the Interdisciplinary Climate Change Expedition. We use that as our core title, and we apply it to all different kinds of environments. ICE Everest, for example, ICE Archie, ICE Glacier, but it's our core, and we've stuck with it because it really sums up what we're doing. All of the work we're doing has some relationship to climate and a changing climatological environment, and also is interdisciplinary across all different kinds of disciplines and trades. So Wyoming, why glaciers? Why this time frame? Why this work? Well, despite the fact that many, many people have no idea that there are glaciers in Wyoming, if you're a longtime resident of Wyoming or have traveled in the state, you know that they're there, and there's many. The actual number can be debated. It depends on if it's named or has completely disappeared or is unnamed. We'll call it about 80. In amidst that is also 680, that's a very specific number. Also, I would say, to be taken with a grain of salt, snow and ice bodies. Some of those we would call permanent ice fields. Some have proven less permanent than others, have disappeared and come back over the years. But regardless, along the Continental Divide, there is a lot of snow and a lot of ice. And for many people in Wyoming, really what this ties into is essentially water. They might not visit the high country, they might not travel there, but they know they rely on the water from it. Before we really dive into the work and why Dinwiddie and where we're going to take this, I want to go back and step in time a little bit. And I don't know if anyone out there has seen the film Chasing Ice. Maybe give me a nod or a hand if you've seen it. If you haven't, I just have to put in a plug for this film. It's stunning visually. It's by James Balog, and his work in National Geographic on glaciers throughout the globe, I think, remains the most highly read National Geographic edition ever. So his work is visually stunning, but it's also really inspiring. So in November 2013, we watched this film with our class in environmental science. It was a brutally cold day, and usually I'm just a driver, and no matter what, we're going outside. And I said, why not? Someone had recommended this film. And we watched it through, and at the end of the presentation, that hush that you feel when you watch a film, particularly on the big screen, and nobody moves and the credits roll, just fell like a blanket over this class, and they sat there. And I had never seen the film before either, so I too was stunned. And one of the students in my class said, Jackie, do you think we could do that kind of work? And it really took about 2.5 minutes for it to start to sink in, and we were off and running. And by February, we had a plan for if we get not one little penny, if we get a few thousand, or if we get $10,000, this is what we can do next summer. So I really want to give a nod to what a beautiful film that raises alarm but doesn't do it through an alarming means, and also a really aesthetic film can do to inspire scientific change and educational change. So in 2014, we started our own Chasing Ice. So not quite the level of James Baylog, perhaps, but our own expedition. We traveled the 24 miles from the roadhead, the bottom left, the bottom of the image, to the Dinwiddie Glacier. And we carried packs of about 50 pounds. This is a designated wilderness area. So we really only travel in the first 3 days with the bulk of what we need for those first few days, and the rest comes in, not by helicopter, not by aircraft, because it's a wilderness area, by horse, and we bring in anywhere from 600 to 900 pounds of additional food and scientific gear. Now, 50 pounds maybe doesn't sound like a lot, but right out of the gates, you gain about 700 feet or more of elevation, and you move quickly to working in high elevation environments. So our students on this expedition, right out of the gates in 2014, got quite a bit and maybe more than what they had bargained for. When we think about the implications of no motorized and no mechanized travel, I think I've had this conversation about 200 times. I imagine you're using drones up there, right? And then a long conversation about how I should use them or how I could use them. It's not going to happen, not by me. The Wilderness Act does not allow motorized, mechanized tools and techniques, and we sit on the Dinwiddie at the base of Gannett Peak, and there are a lot of implications for us having a drone in the air. Could it happen if someone had more sway or more desire or more capacity? Potentially, and would that be a bad thing? Not necessarily, but for us, when we frame this work, it is all by foot access with horse support. And once the horses stop, we travel another 3 miles with our gear, and it's not easy terrain. It's uphill and then across about 1.5 miles of one of those big refrigerator-sized boulder fields to get to the toe of the glacier. So for us, we're looking at how can we be the most creative we can in the backcountry to do the work that we want to do, and we'll talk more about that work. So we come back to 2014, we get ourselves to the Dinwiddie, and pretty much right out of the gates, I was pretty sure we had a story that we wanted to tell. So just to make sure that it was pretty much as complicated as it could be, not only did we pilot a STEM, science, technology, engineering, and math expedition, but we brought in a film crew from Wyoming PBS. Now, if you know Wyoming PBS, the film crew is Kyle Nikoloff and one of our other colleagues from CWC. But we really wanted to take this idea of chasing ice and make it our own. And Kyle started filming in 2014 to create the Wyoming PBS film, Glaciers of the Winds. And if you haven't seen it, he's won several awards for it, and it documents our work as well and the projects that we do in the field. So we come back to why this matters. Well, regardless of the number of glaciers, whether it's 80 or 62 or 95, or whether it's 680 snow and ice fields or 695, this water that comes from the headwaters state of Wyoming, from the Continental Divide, feeds 3 major water resource regions. So the water feeds on the eastern side, the Wind River Basin, the Wind River Reservation, Fremont County, and beyond and beyond and beyond. And I think it's striking to people that this little state that people aren't exactly sure is a state. It is a state, right? It is a state. Yes, Wyoming is a state, and we have glaciers, and our water actually feeds the nation. So when we think about what the implications are for losing this reserve, this savings account of frozen ice that has been feeding the nation, the implications grow dire. So we bring it all together. We're concerned about water. We're concerned about changes to glacial ice masses. We want to bring in geospatial science. And we start this interdisciplinary climate change expedition, and it readily becomes apparent that it's not just how much water, and we'd read various articles. We knew this surface water is between 3 and 25% of the water that comes to Wyoming, could be much higher. But what about water quality? And what about environmental conditions that impact how quickly the ice melts? So we looked at how much water is coming off the Dinwiddie each August, what the quality of that water is. Is it demonstrative of water that we shouldn't be drinking without treating? Should we be concerned about what we find in the water? What about black carbon particulate matter? So from forest fires and incomplete combustion from vehicles, you get little teeny specks, microscopic to the eye, of black carbon particulate matter. We don't see them, but we all know by wearing a black shirt, you absorb more heat, and you start to create this positive feedback cycle of all these various disciplines. We brought to the field to help measure, analyze, and present the work geospatial science, but there's two other things that really come into play for us, and that's wilderness travel and leadership skills. We've tried various elements of running expeditions like that, as have schools throughout the nation. If you've ever led an expedition and you know that people need to be taught to cook, they need to know how to dress, you kind of take people and bring them back to being a baby again. So we set our expeditions up with wilderness travel and leadership skills so that our students can think in the backcountry and can investigate each of these topics. And I want to give a nod to high elevation archaeology. We readily transitioned into two major types of expeditions, both archaeology and glaciology, but that is my counterpart Todd Guenther's work, so I'd be remiss not to give it a nod, but it's not where I'll go today. So as we start to talk about this work, I want to give you a feel for where we're at. At the bottom of our screen, we're looking north. You can see the trailhead at the bottom of the image in the yellow. And as we're discussing the terminus, we're talking about the terminus of the glacier here. When I talk about the water bodies, the glacial tarns at the end of the glacier, those are the ones I'm talking about. And when I talk about the terminal moraine down here, where we do a lot of water quantity discharge measurements, that's what I'm talking about. I don't think it takes an expert to tell that there's been a tremendous amount of change in this environment since the 1850s. So it's phenomenal even just by looking at this image, but we use a lot of tools to quantify and qualify this as well. What did we find when we started jumping in the creek in respect to water quantity? Some of it's the same old, same old. If you travel in the backcountry, you're well aware that if you want to cross creeks, you need to get out in the morning before things warm up and that glacial ice reserve and that snow really starts melting. So we look and measure at diurnal measurements, and on one hand, it's same old, same old. On the other hand, the amount of water that comes out of that terminal moraine I showed you in the last image doubles. So it goes from a trickle early in the morning to a gushing faucet at the end of the day. And at that terminus, right above it, is a really good-sized glacial tarn or lake. So as we watch that, we keep an eye going, is there a point when that runoff is ferocious enough that it blows the bottom out of that terminal moraine and that lake goes downstream? We also saw something else that's pretty interesting from a surface water perspective. You would think in 2017, which was a really, really heavy snow year, I don't know if you remember it, but we were trundling around the glacier and still had a lot of snow on it. You'd think that when we did our water measurements at the end of that summer, that comparatively 2017 with all that snow would be so much higher than 2016. Anybody want to take a guess at what was different in 2016 than 2017? Anybody remember the summer of 2016? Hot, 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 hot. So it was predicted to be 54 to 56 to 60 degrees on the glacier. We were not measuring temperature at that time, but it was hot. And without that protective blanket of the snow, that ice was flooding off of there. So you start to see relationships and these positive feedback cycles where one thing feeds on another. So You lose that blanket of snow, precipitation as climates warm, becoming less likely to be snow. It becomes rain, the ice is open, it gets dirtier, you get more fires, which then in turn put more black carbon particulate matter on the glacier, which then increases the melt, and we lose these frozen reserves. And do need to keep an eye out for glacial outwash floods and lakes moving, as we had happen several years ago in the Wind River Range as well, the Jockalops. So there are hazards to this as well, but also in respect to water availability, there's many considerations. So our students are also measuring, they're capturing snow on the ice, they're measuring black carbon particulate matter, and comparing that across the nation. And on one hand, the results we've had aren't startling because they actually are pretty typical to many, many places across the nation. The catch is, this is the Continental Divide. At 11,000 feet, this is the nation's crown jewel for being a really well-preserved, pristine environment. There's a lot of particulate matter there. Some of it comes from industry and from vehicles and could come from even continents away, and some of it comes naturally from forest fires. But again, once you get these positive feedback cycles building, you start to initiate this pathway of change that you can't quite stall. And if we look at that image on the bottom left there, I guess you're right, pardon me, with each bit of former talus and lateral moraines that get exposed, the rate of melt just keeps going up and up, and the cycle continues. So we've started having students carry portable air quality meters as well, and we'll talk a little bit about that technology and how we've used that, and then we still monitor for black carbon particulate matter. Then there's us. We were sure we would find evidence above the terminal moraine that I showed you earlier of evidence of human waste in the water. Actually, after 2 summers of taking a portable chicken incubator up there and collecting water and comparing it to a control, the first 2 years up high, the water was okay. We did not get any positive dings for E. coli, which is an indicator organism that reflects the fact that if it's there, other things are going to be there. But as time goes on and we start measuring below the terminal moraine, and as the water temperature starts to increase just subtly below the terminal moraine, I think we're seeing signs of change, and there's a whole other project that we could devote all of our time to. But we're certainly watching for our impacts on that environment, other people's impacts, and of course mammals as well. Would I recommend you drink the water anywhere in the Dinwiddie? I would not, but that's a personal choice. We also sample for and look for change in macroinvertebrates and biodiversity. So as the headwaters of the Dinwiddie rise and get closer to the ice, and as this environment changes, we're also seeing changes in the mayflies, stoneflies, and caddisflies that fly fisher people know intimately. And some of this change is hard to assess. Is this bad change, or is this good change, or is this just change? As vegetation increases, biodiversity tends to increase. We're seeing changes in these communities, but this is a long-going study that we will continue, and we have discovered at least the genus of Zapata. If you're a fly fisher person or you studied biodiversity, Zapata Glacier is the stonefly that was endemic to Waterton, and we have found at least the genus, and we found some juveniles that we have to send for genetic analysis there. We use this as an indication of what we might be losing and also what we might be gaining in terms of biodiversity and change over time. So how do you make an expedition like this happen? Mostly we've been focusing on the winds, but also we've had an expedition to East Africa, to Tanzania, and one to Everest Space Camp. It takes a really certain environment. And there's the physical environment. Our student-based station, the Alpine Science Institute, is on the screen. But it also takes a real change in paradigm in community college administration to allow any of this to happen. Believe me, I have caught some royal hell for incomplete paperwork, and yet my institution lets me take students to Nepal and put them on helicopters, and lets me take them to the winds for 3 weeks and to East Africa for a month. This is not your typical community college paradigm. We're a teaching institution. But you can also teach students to do research and you can also teach them about the material through the research. And we have students now who've come up with us on up to 4 expeditions. Even if they were completely resisting my guiley professorial charms of trying to teach them, eventually they would learn something, and quite a lot. So we're grateful to CWC for what they allow us to do. And to get our students ready, I mentioned there's a lot of preparation. Our real secret is that we work across our disciplines, and our outdoor education and leadership professor, Darran Wells, spends 3 months, 6 months, a year getting these students ready. We take them out on an obligatory prerequisite expedition where they have to be able to work together, manage the physicality, and then from there, they're ready to do science. But all of these things, whether it's setting up a bear fence or crossing a river safely, whether it's putting a pressic on a line or learning how to put the equipment onto your pack to monitor temperature, or whether it just is getting along with others, is nothing to be taken for granted, and we're grateful for the fact that we have this team. And then there's time in classes. So it's not always fun and games in East Africa and fun and games on Everest, or headed to Everest in Nepal. If we look at these two, sometimes it's just same old school, doing the work, learning what you need to learn, and writing grants to get assistance to help make these programs happy. Both of these two were with us on our Everest expedition and have been on several other expeditions. And we like to show both sides of the coin on this one. If we start to transition now into geospatial skills, you would think, boy, it seems so simple that just using global positioning systems would be simple. It never is. There's actually much more to good quality data that you would anticipate. And then there's the basics. Can you follow the map? Do you know where you are on a topo? And as we lose that latter skill as a nation, as a society, we're trying to keep that vibrant. It's really important for our field techs, and it's really important to our students. And everything's fine and dandy when you have it on your phone until your phone is not with you anymore and it's broken. And that's a mantra that probably in this crowd I don't need to go on and on too much about. But we keep the classroom skills vibrant. We keep the use of GPS, topo maps, even a straight up old compass. And then we start to transition. That image on the top is communicating what we're gathering for data into story maps and maps in ways that we can share this contemporarily on digital platforms. As we start to dive in a little deeper, we get in really deep. Ground penetrating radar is our longest and most long-standing project. It's probably one of our most technical and one of our heaviest and one of our most expensive. If you're not familiar with ground penetrating radar, it's like an ultrasound for the ground. I'm speaking loosely, but essentially using electromagnetic radiation to measure how long a signal goes through the ice and comes back to assess depth. And it's an art to collect the data, it's an art to interpret it, and it is an art to be able to find a really functional GPR that you can take and haul across by hand on your back 1.5 miles across that terrain. So we've hung on to this project for many reasons, but our real reason for using this was to see, can we use this technology to measure ice depth on the Dinwiddie? There's lots of ways we can qualify and objectively look at the changes. We've seen some of them already, but how does GPR quantify that? We also use structure for motion, so you use a base station to make sure you know exactly where your points are, given points on the ice. So you see me holding the rover there, and then you take, they recommended 2,000. I took 6,000. If some is good, more must be better. 6,000 images, so I could spend months and months and months stitching this together with the software. And what it allows you to do is to create a digital elevation model or a 3D geo-referenced image of your landscape. And each of these projects on the screen have been fantastic learning opportunities for students, and have given us some hard data. The kite aerial photography, it was beautiful. Students loved it. We crashed that kite so hard. We got no data, but boy did those students learn a lot. So to make this work, you need a great environment of administratively where you get the freedom to do this. You need students that are well prepared. You need great professors, and you can tell the old ones on the screen because they all know how to do this. There's me making a point. There's Todd Guenther making a point. There's Darran making a point. You can tell who the old guard are in this because we're all either praying or preaching. I fear it's the latter. And then we've got a couple of new faces, Mara Gans on the bottom right, and Judd Rogers, and there's many, many other people who have helped us out in the field. But I must give a nod to Knowles. We all cut our teeth, with the exception of Todd, who's done a lot of other independent trips, with the National Outdoor Leadership School, and we've taken concepts of those expeditions, all the ones we really love in respect to group management and managing the group organism, and then we've left behind the things that we're like, I never liked doing that anyway. And we've made it our own, but we're grateful to Knowles and the support they've offered for our faculty and some of our other projects. And lastly, you need a great physical environment. So a spectacular backyard, the Greater Yellowstone ecosystem, the Dinwiddie Glacier. Compared to many glaciers, we consider this accessible. A 3 to 4 day travel with a 50-pound pack is reasonable compared to some places you're trying to access in the winds. And I gave a nod here to the Forest Service. We came on as a parasite way back when, inching around in wilderness. And over the past decade, our relationship with the Forest Service has grown in leaps and bounds. And we're currently in a partnership with them where we do work for them in the summer, assessing the impacts of hikers on various areas. And we could not be more grateful. This is a coveted area in the Fitzpatrick Wilderness near Gannett Peak, and we're grateful to have been able to work in this area. And let's say the Dinwiddie and Gannett Peak, 4-day travel in the backcountry in the Greater Yellowstone area, one of the most beautiful places on the planet, is not enough. Well, I get bored so easily that I thought we'd take that partnership with Knowles and UW and we'd blow everyone's minds. So we took Ivy League students from across the country. We had students from Eastern Shoshone tribe and Northern Arapaho tribe, and we put them all together and said, we really wish you luck. But everybody's mind is so blown by everything else that's going on in East Africa, it worked. So we studied the microbiome in East Africa, and there has to be a little bit of icing on the cake. We had the first Eastern Shoshone woman and the first Northern Arapaho gentleman summit Mount Kilimanjaro. And it's something, embracing this kind of diversity, equity, inclusion, and making these expeditions accessible to everybody is something we're tremendously proud of. And maybe hiking's not your thing, but Jacki seems insistent that you start to understand how to wield geospatial technologies and understand what particulate matter is and understand what nitrogen dioxide and volatile organic compounds are. So you ride your bike 1,000 miles along the Great Divide and you carry a sensor and you stay responsible for it. You feed and care for it like it's your dog, and you collect data and you handle that data. And then if you haven't taken environmental science, by the time you're back in the classroom, that data has meaning to you. You get it. It's internalized. It's not just an overnight memorization of the material. So we started in Eureka, and students came back to Lander. That was 3 summers ago. And the emphasis was on asking good questions about air quality and relating the particulate matter and the black carbon we see on glaciers to what's in the air and measuring that and graphing it and presenting their work. This spring, we really mixed it up. This one was an expedition of love and opportunity. Phil Henderson, the first Black Knowles instructor many, many years ago, was the leader of this expedition, is a longtime friend of mine and my family's. And he invited us to come to Everest Base Camp and suggested we work together on a STEM project. And we had some new technology, these portable sensors I'll introduce you to, that we wanted to test. And we figured, what better place to do it? And we really wanted to draw attention to the fact that his expedition was the first all black and brown summit expedition of Everest. They had 6 or 7 successful summiters out of that. And so 80% of our team was comprised of Eastern Shoshone and Northern Arapaho students and 1 first-generation college student. And in case they're still bored, it's like, well, I don't know what else to show you. You know, I'm a middle-aged, boring Canadian expat. How about then we'll spend a couple of days with the leader of the Full Circle Summit Expedition and the first Kenyan to summit, and we'll spend 2 days at base camp. And we'll get their electrical engineer for the team to help you with your tech and do some scientific work. and you'll camp a couple doors down from National Geographic. And if none of this is exciting enough for our students, I got nothing else left. I don't know what else I can pull out of my hat. So we look at these students, and I need to go back a step. When we were on our expedition to Mount Everest, or to Everest Base Camp, I asked some of the Sherpas and guides, so do you see college students very often? He said, oh yeah, Princeton, Stanford, Harvard, Yale. I'm like, right. You don't see Central Wyoming College, open access community college students. Why? Because these expeditions are ferociously expensive, time demanding, and truthfully, there is an element of risk. We manage it the absolute best that we can. But our student group is first-generation students, students at risk, and we've made an extra effort to transition from the population of outdoor ed and rec students of yore, which was, truthfully, predominantly white males, and then white females got in the mix, and then we started cherry-picking a few other people, and we're trying to blow that up and say, you know what? Yes, it is recreation, but it is also science and expedition science, and we can get you jobs in this field just like other fields. It doesn't have to be just play, if that seems trivial or trite. And if you think of when money's tight, vacations are not on your radar. And when money's tight, you're not thinking about how you can escape your life and relax, and you're not thinking about things you can do just for fun. You're really focused on the tasks at hand. So we're trying to make sure that people know this can be a career, and you can integrate these skills, and you can make money at it. And if we frame it right at CWC, we can get students away from the job they might have. They're going to take working at the school as a custodian way over anything I offer them. If I say, I've got this idea, I'd like to conduct undergraduate research, we're going to use some geospatial skills and probably some ground penetrating radar, blah, 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 right? I have to frame it in a way that people go, this is safe for me. She's not completely crazy, little bit, but I can make an income. I'm going to see that income. People are going to welcome me and be kind to me and treat me respectfully. And that's the net that we're looking at. And we're building a new paradigm, just like we're doing within the community colleges, that it's absolute foolhardiness to think that the only time you can ask an original scientific question is when you're in graduate school. Kids this big are doing it. Why? It's on our hard drive. You know, E.O. Wilson said creativity and curiosity are the best scientific skills you can have. So why shouldn't freshmen, sophomore, people coming back to CWC, people who are 50, people who are 21 be able to ask original questions and design research projects? So our students are diverse, they're bold, they're fearless, they'll follow us and trust us, and then we give them the skills they need to lead. And we're grateful to them for the trust they give us, and we are delighted to continue to have all students from Ivy League schools, but also students from Wind River Reservation who lived on this land for thousands of years be on their land. Students from a family that would never spend $5,000 to go to Everest Base Camp. I mean, that's a lot of money by anyone's standards. So we're changing the paradigm and offering opportunities that blow students' minds, that teach them, and that give them something to be proud of that is as good as anybody anywhere across the nation. And they have to bring it all together. Don't worry, I'm not going to walk you through these posters, but we have these great adventures and we come back and there's some long days and some tired eyes working on writing an abstract, understanding the components of a poster, putting together a presentation and having Todd or myself or Darran edit every word and say, no, you can't say that. That's beyond the scope of what we did in this research. Back it up and get it right. And they do. They share their work at Undergraduate Research Day. They share their work when we add an A, so we add A for arts, science, technology, engineering, arts, and math, through imagery. So on the bottom left is Antoine Day, Eastern Shoshone. he was our photographer for our Everest expedition. And he's a natural at whatever he does. But for that expedition, he took our photographs and then created a full-on art exhibition called World on Fire. And that was up at the CWC Arts Center until recently. And then also on the bottom left, Aidan Hereford, Jada Antelope, and Antoine again, all playing a role in describing what we did on that expedition, how it ties into science, and what it does for them as people, giving them an opportunity to tell their story. So there's pure science at the scientific conferences, and then there's the human story, and all of those collectively matter, and especially if you're trying to build not just STEM competence, but STEM confidence, you have to give people the opportunity to shine at the things they already know about a little bit. If we look at where we're headed next and some of the technology we've used that are, I call them bridge technologies. They all have a location aspect to them, but they also bring in new information. We're using a new unit called a Medio Tracker that's made by a group in Italy, and this other product from France, which is called the Air Quality Flow Plume Meter to monitor air quality. And there's a reason that fixed air stations and fixed weather meteorological stations are complex and cost lots of money. It's really hard to do good in situ data collection in this field, but we're trying to, and we're trying to because there's some really significant gaps, both in the Dinwiddie and in the winds, and in other high elevation glaciological and hydrological regions of the world. You may have seen some of the Nat Geo articles about putting in these expensive base stations in South America. It's really expensive to put in a weather station. Somebody has to monitor it, and just one expedition could cost $50,000. So we're trying to help teach and engage by bringing our students, and in the future the community, into trying different portable technologies and assessing them for quality assurance and quality control to get good data that students can handle, community members can handle and interpret, and that allows us to access areas for which there's little information. If we look at the Dinwiddie, some of what we've done is super quantitative. Some of it can be qualitative. You don't have to have a real scientific eye to see drastic transformation. So as we look at the various places we've been and how these skills help prepare students for an uncertain future, we're going to bring things back a little bit and look at the Dinwiddie Glacier and bring in just a little more of a few specific scientific and analysis details before we close today. So 1951, Mark Meyer, people might know him. He was the impetus for starting InStar in Colorado, CU Boulder. His thesis in 1951 involved a lot of repeat photography, and so we have adopted that as well. I poo-pooed it initially thinking it had to be quantitative, but you can tell quite a bit just from that picture. Where does that water go? Well, some of it ends up in those glacial tarns down here, and these are a lot bigger already. Those are big at this point. Some of it ends up above the terminal moraine, and we're starting to pay attention when we're working down there that that terminal moraine doesn't blow, and some of it feeds the state, but this water is a big deal. If anyone's interested, we have conducted a repeat photography of about 8 glaciers actually in the Wind River Range, doing repeat photos, going to those areas, marking out the spots that Mark Meyer did in 1951, and our students have been part of that as well as our faculty. Coming back to what we actually found when we used ground penetrating radar. I'm just gonna roll with it. Well, you saw it from the pictures, but we saw a big change. We repeated a transect that was done in 2006, and when we specifically sought to find out how much ice we'd lost on the Dinwiddie between 2006 and 2016 along that same transect, about 16 meters of ice depth. We're now revisiting that, and I'll explain that in just a second, but we look at some trends, areas where we knew there was probably a lot of ice over on that upper, we'll call it the upper northwest corner there, and down in yellow where there was minimal ice. So this is from 2016. In 2019, the USGS flew LIDAR, light detection and ranging over the winds, and we got the the most accurate data we could get that we can use as a baseline to compare our fieldwork to and to compare against over time. And so now, some of the work we've done in the past has been simply going for a stroll on the glacier and mapping the perimeter. This is okay, but there's some human subjectivity that happens there, and I've walked each one of those lines, and I know that I don't want to end up in the brink, so I keep a bit of a buffer against the water. And a glacier's area in advance doesn't tell you all you want to know about its depth. So adding in LiDAR and giving us something to which we can compare is spectacular. And for any of my students who are watching this, I know this isn't the world's most beautiful map. I've just started working with this data, but we looked at the 1996 line that was done by Cheesebrow that we've tried to replicate, and compared that over time. And the amount of ice we think we lost along this same line over time is staggering. We're thinking probably around 30 meters, probably potentially considerably more. And we're just beginning to really dive into this data. And I draw attention to something. You have to have the GPR, you have to have something quantitative. But we know this moat. Back in the 80s, we would do a snow school there, and we knew that the rope length, you needed a full rope length to get from top to bottom. Now at this point, it's about a third of a rope length to drop into there. So we see it, we feel it, we measure it, and we photograph it, but we know change is upon us. Also of interest that you see when you're on the ice and you're out in that environment are these tarns here. They're much, much bigger already than this image, which was taken in 2020. And we've also started to pay attention, this is at Everest Space Camp, but we see these same pillars, and we've watched them for years and years and went, that has to be what we think it is. That has to be a measure of how much ice we saw each year. And one year it's 2 meters, and the next year it's a foot, and then there'll be a little baby esker at the bottom of the glacier that's 2 meters high, and you go, oh boy, it really is that. Now there's going to be some error depending on when you see that and when you measure it, but we've seen these on the Dinwiddie for many, many years. And I've actually never seen them in a textbook. I just saw an article written about it and was afraid to even be bold enough to go, is it as simple as that? It's where the rock is on the top and how high the ice is how much you've lost? It is. It's almost that simple. So what next? As I get close to wrapping up here, we want to really help further the science of high elevation environments in Wyoming. In wilderness areas, there are some snow-tell sites where you can measure precipitation and have some idea of meteorological conditions over time. There's numerous snow-tell sites throughout the state, most of them in treed areas, because that's where most of the snow is. So we haven't bothered really to put those up high, in part because it's wilderness, in part because they're really terrible to manage and hideous to access and difficult to maintain. So we want to take those other devices, the Meteo tracker that you saw, and encourage hikers that are hiking the Continental Divide Trail and the community to participate and start feeding us some data. We talked to Brett McDonald from the National Weather Service, and he says, I couldn't tell you 3 days ago what the real temperature was at Dinwiddie. I can't tell you if the nights are getting warmer. And everyone's asked us over the years, well, do you take a thermometer? And I said, well, no, because the ones that are out there are such junk that no matter what, I'm going to lie. If I say it's getting warmer, I'm going to lie. If I say it's getting colder, I'm going to lie, because the accuracy is just not there. So we're hoping to use the Meteo trackers to help monitor and georeference temperature change and relative humidity. It also has an air quality probe. We'll continue to do that. And then it has a water temperature probe. So we'll start to capture changes and look for relationships between harmful cyanobacterial blooms. I got confused. That's the wrong arrow. I don't have my glasses on. There we go. So ice climate is our next project. And we're asking the question of, can portable sensors be used to characterize these high elevation environments? Which ones are the best for this work? And how does this data compare to interpolated weather data and modeled climate data? And this is a pretty lofty goal, but if not now, then when? And if not by us and our community and participants in the state, then who? Also on our horizon are for our Eastern Shoshone and Northern Arapaho students. They will do their own sort of re-indigenization connection to the landscape called New Voices, Native Environmental Wisdom, Voices and Outcomes in Climate and Environmental Science. It's science, but this group will be the first, to our knowledge, Central Wyoming College anyways, purely indigenous expedition doing science in traditional lands. And we hope to teach these kids to do some podcasting and tell their story, not me telling their story for them, but them telling their story from their own hearts and their own experience. That will be happening this summer at the end of the summer. And for the only complex graph, a scientific presentation, there has to be some graphs. I think that's about an hour and a half of figuring out who funds what and where and when. You can't craft an Ivy League expedition and you can't embrace diversity unless you fund it and take care of people well. And that's from day one right through to they present their work. So to all of the people on this screen, thank you so, so much for funding these expeditions. These students do not pay for them, and in fact, they get a research stipend to participate once they've presented their work. And to all of them who've funded our work in the Winds, in East Africa, Everspace Camp, on our bikes expedition and beyond, we're forever grateful. So thank you, and thank you so much for your time. I'll take any questions.